Adam, and we're continuing with AS electricity because अभी उसी topic को हमने शुरू किया, तो I want to end that topic with you first. It's a very long topic, but I'll try to cover it as fast as I can. My advice to you would be that that you continue practicing as we go. So जो छोटे concepts हैं, like I'll give you an example. We did a concept in which you said resistance is proportional to length, and we proved this relationship. Now, what you should do is, using your topicals or whatever resource you're using, you should find questions which are based on this concept and then apply those concepts and see if you get the right answer or not. So one of the questions that I very recently got from a student. Yes, actually, that reminds me. One thing that you should do is use my YouTube page as a community page as well. So if you have a difficult question, for example, and you're looking for a solution, just post the question beneath it, and I would request the whole community to address the issue. I will also be appointing some moderators in the group who can help answer the questions in order to facilitate your learning even more. So, yeah, and that's something that I'll work on very immediately. So one question that I came across this relating to this concept that I'm telling you of resistance and length and area was that, let's say you have a wire of resistance 2 ohms. So we have wire 1, which has a resistance of 2 ohms, okay? And wire 1 has a diameter D, and wire 1 has length L. Now, a statement, just one statement that they wrote very conspicuously, but it was a very important statement, was like the wire is stretched, so the diameter decreases by half. The diameter decreases by half. What is the new resistance? Now, most of the kids end up thinking that, this is diameter, so we had done this before, that resistance is inversely proportional to area. That means resistance is inversely proportional to diameter squared. Now, you are saying that the diameter has gone down by a factor of 2, so the resistance should increase by a factor of 4. That is wrong. Why is that the wrong answer? The concept is not wrong. The concept was that if the diameter has gone down by 2, then the area must go up by a factor of 4. The resistance, must go up by a factor of 4. The concept is, dekhen, area is proportional to diameter square. Okay. Area is proportional to diameter divided by 2 whole square. So जब ये diameter divided by 2 करोगे on this side of the equation, then naturally you will have to do a divided by 4 on this side for them to be proportional again. So that means your area goes down by a factor of 4. Now, if area goes down by a factor of 4, resistance and area have an inverse relationship. If area decreases by 4 times, then the resistance must increase by 4 times. So baat to theek hai, matlab it makes perfect sense. Now I'm telling you that although it's a wrong answer, but how to approach it. Whenever they say that the wire is stretched so the diameter decreases by half, you should always think of this relationship. No need to go into this area and then converting diameter to area and then it'll just waste time. It's an MCQ. So just use this relationship directly. Resistance is inversely proportional to diameter square. Diameter decreases by half. So what is 1 by 2 square? The answer is 1 over 4. And because they have an inverse relationship, so if the diameter goes down by a factor of 4, the resistance will go up by a factor of 4. All right. Now, that is a basic maths concept. But in this case, in the case of this question, it is the wrong answer. And the reason why it's wrong is you did not look closely enough at the question. This is wire 1. They did not give you the the diagram you should make 1. This is wire 1. Now, when you will make wire 2, and wire 2 is stretched, so the diameter is halved. So think about it. कि अगर आपका diameter d है और अब diameter हो गया d divided by 2, तो क्या आपकी length increase नहीं हुई होगी? Of course हुई होगी. पहले initially your length was L. Now your length will be twice of L. And remember, the reason for that is that the volume must remain constant. Volume must remain constant. Now, there will be questions where he will explicitly mention this. If he doesn't, then you have to assume that the volume remains constant. But it's the same amount of wire that you've used. So the volume must remain the same. If the volume has to remain the same, then definitely the length must have doubled. So based on this thing over here, let's apply it to the question again. So we said that resistance is proportional to length and inversely proportional to area. Now, area ki jagah you can write diameter square, so I can say resistance is proportional to length over diameter square. Now, the same thing. The diameter went down by a factor of 1 over 2, that's 1 over 2 squared. That means that your resistance must go up by a factor of 4. That is just due to the diameter, remember. Now let's take into account the length. Your length increased by 2 times. That means your resistance has to increase by 2 times again. So that means that your resistance is actually increasing by 4 times and then by 2 times. So that means that your resistance increases by 8 times. So if your resistance is increasing by 8 times, so that means that if originally your resistance was 2 ohms, then 2 into 8, the answer is 16 ohms. Do practice a lot of such questions. Now they do come and they tend to confuse a lot of people. All right, that is one concept. The other concept that I want to discuss in this lecture with you today, very quickly, series and parallel combinations. Now, in series and parallel combinations, again, we will rely on your O-level knowledge. O-level से आपने सीखा हुआ है series का formula, that is R is equals to R1 plus R2 plus R3. This is for series. Now, you must know how to prove this relationship. So, you take a cell, you put 3 resistors or 4 or whatever in series and call them R1, R2, R3. The cell has EMF E, and let's say there's a current that is going in. Now, remember that for series circuits, you rely on the law of conservation of energy. Law of conservation of energy. Now, when you're relying on the law of conservation of energy, that says that your EMF E must be equal to the potential drop across the first resistor, the potential drop across the second one, and the potential drop across the third one. So E would be equal to V1 plus V2 plus V3. They can ask you this question that while proving a series circuit, what did you use? So you must remember that you use the law of conservation of energy. Now, EMF is equals to energy lost against the first resistor, the second one, and the third one. V, potential difference. Potential difference energy का नाम है. EMF भी energy का नाम है. फर्क क्या है? Energy E is always connected or related to the cell, और जो V1, V2, V3 potential difference is always connected to the load. So remember that E always refers to the source. Cell हो गया, battery हो गई, generator हो गया, and the V's always connect to the load or give you the idea that, okay, this is the load side. So basically what we're trying to say is that the energy that you've supplied in the source must be equal to the energy that the loads have consumed. Energy conserved. Energy supplied is equals to energy consumed. Now, एक trick कभी नहीं भूलना आपने. Now, in the last lecture, we did Ohm's law, right? V is equals to IR, prove किया था. Please remember one thing, and I'm repeating, note it down somewhere very carefully. Whenever instead of V you write E, kabhi bhi, in any question, if instead of V you write E, then this current has to be the total current and the resistance has to be the total resistance. Never forget that. If in a question आप गलती से भी सेल का EMF डाल देते हैं, ठीक है, 2 वोल्ट्स के मैंने डाल दिया और इस रजिस्टर की वैल्यू डाल दी निकालने के लिए करंट कितना था इसमें, आंसर गलत आएगा। प्लीज़ याद रखिएगा, इफ़ यू आर यूजिंग ई फॉर एनी कैल, को कहता है जी इसके अंदर इस रजिस्टर में से बताएं करंट कितना है, और आपके पास कोई और तरीका नहीं है, you don't have any other way except for you to use E, then believe me, if you're using E, you cannot just put the value of R2 and R and say, oh, I have the current. No. If you're using E, then has to be the total current and has to be the total resistance. So you'll have to add the 3 resistances and then put them here if you are using the cell's EMF. Remember this fact, EMF के साथ हमेशा I total, R total आएगा. Now, whenever you are using the other side, which is let's say V1, a V1 is not the cell. Cell देखो, the cell is providing to the whole circuit. Cell एक का नहीं है, cell सब का है. V1 सिर्फ R1 का है, V2 सिर्फ R2 का है, V3 is just for R3. So try to understand that when you're using V1, you must only use R1 if in case you're using V is equals to IR. If you're using V2, finding V2, then you use I to R2. V2 has nothing to do with R3, V2 has nothing to do with R1, at least in the calculation over here. So V1 is equals to I1, you can call it I1 into R1. It really doesn't matter whether you call it I1, I2 or I3. The reason for it is, it's the series circuit. In a series circuit, you've got a single wire. Remember, if you have a single wire is always equivalent to a single current. So आपने नाम उसको और देना, you want to name it differently, doesn't matter, you'll just complicate your own task. I would suggest give it the same name. So IT. So now I'll populate the equation. So I get I total into R total is equals to I total into R1 because I was talking of V1. So remember, when talking of V1, you're talking of a particular resistor. Again, when you're talking of V2, you'll write I total into R2 plus I total into R3. Now, since you're in a series circuit, you have a single wire, single current. So the currents are the same. So you can eliminate the currents. And when you eliminate all the currents, you end up getting R total is equals to R1 plus R2 plus R3. All right, great. Now, in the same flow, let's quickly go over what parallel circuits are. Now, in a parallel circuit, you must remember that the formula is 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3, and you can keep on populating that list. Again, let's quickly run through the derivation. So you have 3 resistors in this case, like this, and they're connected to a cell. One thing about parallel circuits that you must remember, जो मैंने आपको पीछे पढ़ाया, you must see that you have 3 different wires over here. So one path is this one, another path is this one, and the third path is this one. All right. One thing which you must understand, that the current that is coming from the cell, that is I total. This is EMF E. Now, what you notice is that you have multiple wires. So first it was single wires and current. Now you've got multiple wires, you've got multiple currents. So some part of the current will go over here. Let's call it I1. Let's call this as I2, and let's call this as I3. Let's call this resistance as R1, R2, R3. Now, remember that for parallel circuits, they rely on the law of conservation of charge. Now, when you use the law of conservation of charge, that means basically the current is conserved, which means जितना current आपने supply किया है, you will get the same current split in the 3 different or 4 different branches. No matter how many branches you have, the total current will always be equal to the current that's coming from the cell. That's one thing. The second thing is, in parallel, the voltage remains the same. So you might have noticed मैंने V1, V2, V3 नहीं लिखा, because in सब के across जो voltage है वो same है. और वैसे क्यों है? Please try to understand. So let's consider the positive terminal, and I'll move the positive terminal from here to here. Okay. Did you notice any resistance along the way? The answer is no. So that means that this positive terminal can come over here. Now let's move the negative terminal. If you move the negative terminal, you can bring it all the way here. Did any resistance come in the middle? The answer is no. So this negative terminal is also over here. So therefore, अगर battery का positive और negative terminal दोनों यहाँ तक पहुँच गए without any obstruction, that means that the voltage over here is E. Let's try it for the second one. Again, let's drag the positive terminal down all the way till here. कोई resistance नहीं आई. That means this positive terminal has come over here. Let's drag the negative terminal down and bring it over here. कोई resistance बीच में नहीं आई. That means that the positive and the negative of the cell have successfully reached this point without any obstruction. That means that the EMF E is across this resistor. And likewise, you can do the same trick for R3. So that means in parallel, the voltage will always remain the same. Okay. Now, Ohm's law was V is equals to IR. So current is V over R. So you will write E instead of I total. Remember, वही वाली बात. Whenever you want to use this symbol total, you have no choice but to use EMF. Why? क्योंकि EMF एक का नहीं होता है, EMF सबका होता है. और जब EMF आ गया, now you should ask yourself, R1 डालेंगे, R2 डालेंगे यहाँ पे, या R3 डालेंगे, या R total डालेंगे. Ask yourself कि EMF है तो क्या होना चाहिए? The answer to that, I hope, is R total डालेंगे. So I total is EMF over R total is equals to now. Now when you come to I1, now I1 is specifically in this part of the circuit where the EMF was E, but now you're in a particular part of that circuit. So you will write E over R1. आपके ज़हन में अगर अभी आया है कि जी अब EMF यूज़ किया है और EMF यूज़ करके अब क्यों नहीं डाला R टोटल, उसकी वजह ये ट्राई टू आस्क योरसेल्फ कि जब ये आपने EMF तो यूज़ किया, पैरेलल में वोल्टेज सेम है, हम EMF के अलावा कुछ यूज़ नहीं कर सकते, बट यहाँ मुझे बताओ करंट जो आया है क्या वो सारे का सारा करंट आ गया सेल का या कुछ हिस्सा उसका? द आंसर वुड बी कुछ हिस्सा, बिकॉज कुछ हिस्सा नीचे भी गया, कुछ हिस्सा नीचे भी गया. तो इस वजह से हम R1 लिख रहे हैं, R total लिख रहे हैं. ये I total की जगह ये क्यों लिखा? बिकॉज I total इज दिस करंट दैट इज कमिंग आउट फ्रॉम द बैटरी. बैटरी से सारा करंट जो आ रहा है वो सबके लिए आ रहा है. दैट इज वाई राइट E over R total is equals to E over R1 plus, now again you come to the lower one, the EMF is E, but because you're talking of a particular current over here, which is this one, so you end up writing E over R2 plus E over R3. So the E's get cancelled and you end up getting 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Brilliant. ये दोनों formulas आपको derive करने आने चाहिए. The derivations are very much part of your syllabus. Are we clear on that? All right, great. Now, just a little reminder for you that if you are solving two resistors in parallel, so for that you have a shortcut. Let's write in the formula very quickly. 1 over R total is equals to 1 over R1 plus 1 over R2. Take the LCM on the right hand side, you'll get R1 into R2. Numerator में you'll get R2 plus R1. This is 1 over R total. So basically R total निकालना होता है ना. So R total will be R1 into R2 divided by R1 plus R2. Very useful formula. बहुत फ़ायदा देता है and it's very easy to use whenever you have two resistors in parallel like this. Okay, connected to any other circuit. Let's say this is R1, this is R2. इनकी total resistance निकालनी है तो वो आप यहाँ से निकाल सकते हो. All right, great.